This video goes through a few examples of some word problems that require you to use trigonometry in order to solve them. This is the bottom of section number 5 in your Unit 8 Trigonometry flipbook. Essential question is, how do I use trigonometry to solve word problems? How do I use trigonometry to solve word problems? Let's take a look at a couple of these. I think some of these maybe you've already seen in some situations. A ship uses sonar to find the location of an enemy submarine. What is the horizontal and vertical distance to the sub? And you can see here we have H. There is our horizontal distance to the top of the sub, and then D is our depth to the actual submarine location. So you can see, class, that actually sonar does use trigonometry to calculate how far away a submarine is. It knows the angle of descent, or the angle that the sonar array is pointed in the water, and it can use trigonometry to figure out the different measures. So how do we do this? Well, it's a trigonometry problem, so you know the two things we're going to do is we're going to label the hypotenuse, and we're going to write SOHCAHTOA. Okay. Actually, let me turn to the right page as we're working on this real quick. Hang on one sec. All right. So first of all, let's go ahead and try to find the value of H. Let's do that first. We could have done either one. Now, class, I'm going to shortcut a couple steps here. We're looking for the value of H. I'm going to look at my reference angle, which is right here. So our reference angle is 35 degrees. And if I want H, H is adjacent, and D is opposite. So I want adjacent, and I know hypotenuse. So adjacent and hypotenuse is cosine. So to find H, we're going to use cosine of 35 degrees is equal to, remember, cosine is adjacent over hypotenuse. Adjacent is our unknown H. Our hypotenuse is 400. All we have to do now is get H by itself. In this case, since H is on the top of our ratio, we're going to multiply both sides by 400 to get H by itself. So 400 times cosine of 35 is equal to H. And so we can go ahead and plug this in our calculator. H is going to be approximately, let's bring up our calculator here. Slide it over so you guys can see it. And I'll clear it. We've got 400 times cosine of 35 degrees. Oops, I got two. Sorry, I didn't notice that the calculator already put the parenthesis in there for me. There we go. 400 times cosine of 35. Press equal. We've got 327.6. Let's round that to 327.7. So 327.7 meters. There is our first value. I'm going to write this as a sentence. The horizontal, if I can write that correctly. See, class, when I'm rushing and writing small. The horizontal distance is 327.7 meters. All right, let's figure out the depth, or the vertical distance. So we're looking for now D. And for D, I'm going to use the same reference angle, 35. D is opposite. We know the hypotenuse. Opposite and hypotenuse is going to be sine. So we're going to use sine of 35 is equal to, opposite is D, hypotenuse is 400. Look how similar this looks to the previous question, class. All we did was change cosine to sine in this case. We're going to multiply both sides by 400. So we have 400 times sine of 35. The reason why, class, is because our variable is on the top of our fraction. So we multiply by 400 to cancel the 400s here, which moves the 400 to the other side. That is equal to D. And we can go ahead and plug that into our calculator. You see how fast this gets as you begin to practice your trigonometry. Let's go ahead and type in 400 times, in this case we're using sine of 35, close parentheses, press equal, 229.43, so we can round to 229.4, approximately 229.4 meters. Let's go ahead and write this as a sentence. The vertical. We could have also said the depth, but because the question says vertical distance, we'll just go ahead and use the same word that they used in the question. The vertical distance is 229.4 meters. There's our first example. Let's take a look at the tree height problem. Given the length of the shadow, so we have a shadow coming off the tree. That means the sun is over here somewhere. Let's draw a little sun. Okay, the sun is over here making a shadow. Given the length of the shadow, which we know is 82 feet, and the angle of incidence, class, angle of incidence is where we are measuring an angle from the ground. So in this case, the angle of incidence is 48 degrees. What is the height of the tree? Okay, well, we know right now, class, we're going to use this as our reference angle. This is hypotenuse. H must be opposite, and the 82 feet is adjacent to our angle. So we're going to write so, ka, toa. Let's go through all the steps now just to practice this again. Our reference angle, we don't even have a name for it, but we can just say it's just 48 degrees. We know, what do we know? We know adjacent. What do we want to know? We want opposite, which is h. So let's check our trig functions. Adjacent and opposite, adjacent and oops, that's not adjacent and opposite. Adjacent, adjacent, opposite, opposite. Looks like we have to go with tangent. All right, let's write our equation. Tangent of 48 degrees is equal to opposite over adjacent. Opposite is our unknown value h. Adjacent is 82. Our variable is in the numerator, so we multiply both sides by the denominator to get the 82 to go to the other side. 82 times tangent of 48 equals h. And that means h is going to be approximately, let me fix that, h, that's still terrible. We'll put that h back. H is going to be approximately, let's pull up our calculator. And I will plug in, oops, I just went off the screen, I can tell. I don't have much room anywhere. Okay, let's try it right here. It's going to be 82 times tangent of 48 degrees. Press equal. We got 91.07. I can round it to 91.1. So it's approximately 91.1. Our unit of measure is feet. So here is our sentence answer. The height of the tree is 91.1 feet. Remember, class, a word-based question deserves a word-based answer. All right, we got 6 more minutes. Let's see if we can do this next one quickly. Another story. I can see I got a cabin here, another cabin on an island. Looks like I've got a trigonometry question. To find the distance d, which is this line right here, from a house on the shore to a house on an island, a surveyor measures from the house on the shore to point B. Looks like you got 40 meters here. If you can't read that, class, it is 40 meters. And as shown in the diagram, an instrument called a transit, that's what surveyors use, transits give you distances, is used to find the measure of angle B. Estimate the distance D. So they figured out that angle B was 42 degrees. That's going to be our reference angle. Let's go ahead and label here. We got hypotenuse is right here. From angle B, D is opposite, and the 40 meters is adjacent. All right. Let's take a look at what we got. We got SOHCAHTOA. Our reference angle, we don't even know. Oh, it does have an angle. It's angle B. The reference angle is B. We know, let's see, what do we know? We know adjacent. We want letter D, which is opposite. So we're going to use adjacent and opposite. Adjacent and opposite is tangent. So our trig function is going to be tangent. Our reference angle is 42 degrees, is equal to opposite, which is our unknown D, over adjacent, which is 40. This is looking a whole lot like the previous question. Let's move the 40 to the other side by multiplying both sides by 40. And 40 times tangent 42 equals D. And that means D is approximately, let's take a look, get my calculator out, move it to the other side. We got 40 times tangent of 42 degrees, press equal, and it's 36.01. So we're going to round that to 36.0. So we've got 36.0. So our final answer is, I can just write this, the distance is 36.0. And I know it's hard to read, but this is labeled 40 meters. So 36.0 meters. There are some good examples of using trigonometry to solve word problems.